to just say by an exercise. Yep. Okay, so any more questions about 218? 1. Okay, number 2?
Okay. We have these two inequalities that we're going to show justify this inequality. We're going to take the first one and break it down into its parts. We have x is greater than 0, so we can multiply it. Then we have these two cases, so we have, in particular, we can use transitivity to show that y is greater than 0, so then we can use that for multiplication. And also then we have the second part, transitivity, we have 0, well, z greater than 0, so we can use that for multiplication. And then we have these two parts, the x and the x less than y and z greater than w. By multiplicative property, we multiply out a w and we multiply out a y. And then we get this, and by transitivity we can take out the middle, and then we have that inequality, that inequality right there. And for the equals, we just take this and multiplicative property, throw in the x, and then substitute in the y.
Okay, just to be safe, when you mention the multiplicative property over here, it's a good idea at this point to just put a little reminder that that what?
It has to be greater than
what? But what has to be greater than 0?
the thing that you're multiplying.
Which is?
This time x.
Yes, so I would just put a little reminder in there, right? Since x is greater than 0, use the multiplicative property. Or you could just, you could also just, just put in here, just put in parentheses, just so you let me know, this is for, I almost put less than there, right? Okay. If you put that in there, just as because you should also be thinking about this. You should be scared to use the multiplicative property, because the multiplicative property does not work unless it's positive, or if it's negative, it flips the inequalities, and if it's 0, of course, it wipes everything out. So, okay. So, any questions about what Michael did in this problem? By the way, what this tells you is that if everything is positive, you can do something, and let me also look at case 1 here. This tells you that you can add, and it's also 14, right? It tells you that you can add inequalities. You may have, done this sort of thing, right? So this gives you a real shortcut, and you can do that for a whole string of things, right, and add them like that. This gives you a real shortcut to work on things, right? And so this is now proved, so you can now use it, unless I say you can't on the test.
Will it also preserve the equals if it's less than equals?
Well, right. So that's one of the other cases here, right? And this is telling you that yes, right? I mean, so this was just case 1, but this tells you that in fact, if you have less than or equal in there, as long as they're all going the same way, if you have C equal D, well, no, I don't want that, right? So E equal F or something, right? Then this becomes. Sorry, no, it becomes that. We still preserve that, right? Yes. The only time it's going to be equals is when they're all equal. Okay? Okay, so I will see you next, I guess, on Monday after the test. Your homework for Monday is to read over what we did last time, because you're going to have to be on top of these lower bounds, upper bounds, sup, inf, because I'm going to launch right into that with only a little bit of review.